Okay. Hello, everyone. Thanks for being here. Oh, it's like really full. I didn't expect that. I'm really happy that you're all interested in GraphQL. I mean, I was interested in GraphQL, I think, but I'm not sure. Well, no, okay, I'm interested in GraphQL. So I'll try to cut the least important stuff because I prepared this talk for 40 minutes duration, but we only have 20, so I'll try to run as fast as possible. So if you have any questions, I don't think that we can take questions in this session, but if you have questions, like find me outside. Most probably I won't be able to answer, but if I am, I'm glad to answer. Okay, let's get started. So first of all, a lot of people think that GraphQL is a replacement for REST. Well, that's not true. They solve two different problems. And they have actually quite a lot of differences. So who of you already used GraphQL, apart from this side of the room? Okay, I'm curious to know why you used it, not from you because I know, but from the rest of you, I'm really curious. Why would you use GraphQL and why you chose what you choose to use and what tools are you using? But first, let's start and see a few differences between all that is related to REST and all that is related to GraphQL. So, first of all, we are comparing something that is more of an architectural pattern to something that is some sort of SQL on steroids. So, well, they're different. I mean, we can architecture our whole app around RESTful services, while with GraphQL, well, we basically just say, yeah, I just need to get the data in this slightly different way, so that's fine. Also, well, we have a lot of tools now for everything related to REST. Like on Android, we have Retrofit, and we see that we have something almost as nice with GraphQL as well. Another very important thing is that when we talk about RESTful service, we usually are relying on the lower levels communication transportation layers. We don't really care what we run on because REST should leverage it. While GraphQL doesn't really get that far. It enforces its own conventions, and well, it might leverage what it finds below, but it's not said that it will. For instance, some instances of GraphQL might use HTTP status code for errors. Others may just send you an empty response. It just depends on how the backend manage those errors and how you actually expect them. So when you're almost sure that when you have a problem with Retrofit, you'll get an exception, well, this is not said with GraphQL. Well, an aspect that is really, really important is that unless you own your REST endpoint, that means that your team can actually change how the response look like and what data you are getting back. Well, you get what the backend wants. So if you have 3 platforms that request data from the same endpoint, well, the response will be the same for all the clients. Unless, again, you actually own the endpoint so that you can actually tweak the response and just get what you need inside your app. So imagine that for iOS, you will need 2 different titles and a description. While on Android, you will need a title, a subtitle, a description, and a link. If you have a single endpoint, you have to actually sum all the fields that are not common and have a huge response. Unless you own the endpoint. At that point, you have 2 different responses. With GraphQL, each client can request what they want. So if on Android we need 4 data, we'll just request for 4 data. If on iOS we need 3, we request 3. So it's a different approach. Again, this is not said for every RESTful endpoint out there, and well, someone can actually choose to use the same GraphQL request for all the platforms. But in general, if you don't own your REST endpoint, you get what the backend think that everyone should get. While with GraphQL, you're getting what you request. Another thing that is actually one of the strength points of GraphQL is that we have only one endpoint. No matter what you're requesting, you're gonna make the request to the same endpoint. For instance, if you want users and news, you're gonna query the same endpoint. While with most RESTful services, you might have an entity which is under user, another one which is under news, and you have to make 2 requests in order to get the same data. Also, with the fact that we only have one single endpoint, we don't really care about the relations. I mean, we can build them in our query. With REST, we always have to think about, oh wait, this might be under user, this other might be under news. Oh well, that's different. So you might end up having to make multiple requests instead of one. Again, if you don't own the endpoint, because this is really important in these differences. So we talk about the main differences, but what is actually GraphQL, or actually what composes GraphQL? Well, of course there are a lot of parts about this project, but since I'm an Android engineer, and I guess most of you are, well, we don't really care about backend. I mean, I don't, and I only care about what has to be inside my app. And GraphQL, for what concerns Android, is basically built upon 2 parts. The first part is this thing here, the query. This is what we want to request. So this is basically a list of properties and a list of objects with related sub-properties that we want to get. There's no limit of how deep this query can go. I mean, we can go like 7, 8 level deep, and that's fine. But of course, in order to know what we can actually query for, we need something else. And this something else is a huge JSON file, which is called the schema. So the schema is the contract that the clients and the providers, the backend, agree on. That means that this schema contains all the elements that we can query, all the different objects, how those objects can be possibly connected, and what kind of return type we should expect. If those return types should be vectors, or should be nullable, or should not be nullable. What function can we invoke? If these functions actually need parameters, if these parameters, again, can be nullable or not. So this schema is actually pretty huge. And usually you need to download it every time the schema change. It should not change once you agree upon it, but well, it may happen that actually changes. As we said, we are Android engineers. So but we need a solution to make all this stuff work on Android. Because under the hood, it's just a network request that pass a huge payload. But, well, I don't really want to do this by hand every time. So luckily there is a library which is called Apollo. So why should we use a library? Well, why should we use a library? That's a question that is, well, we already answered that. I mean, we all use libraries in our projects. But why should we use Apollo instead of rolling our own solution? Well, Apollo has 4 main strength points. The first one is the compile time safety. So how many of you already used Swagger for REST API? Okay, did you try that plugin that can generate code upon based on your APIs? So basically, you include it in your project, and it will generate the classes that you need for as your return types. So it's actually pretty nice, right? Well, we get the same with Apollo. Unfortunately, it's in Java, so but we don't really commit generated code, so it's fine. So what happens there is that based on your schema and your query, it will generate all the classes that you need, starting from the request and getting to the response, so that you have an object in Java that maps exactly what you request to the backend. That means that you have like 8 or 9 subclasses inside, you will get the same exact object. And that means that you have to parse it later. But of course, if you make a mistake in writing the query, well, you will know right away. So you don't need to compile. Actually, you won't be able to compile if there is something wrong with your query. Another thing that we get from Apollo is the optional caching level. Because GraphQL doesn't really say that we should cache anything, but caching is another problem. It's not easy to solve, and not everyone has the time to actually think about a caching strategy. So they provided an optional artifact that can be included and will actually provide a caching layer if you only use Apollo. If you have other solution like repository pattern or whatever you implemented, you might not need the caching layer, but it's good to actually have it ready there. And of course, Apollo is an open source project. That means that there is a huge community behind it. Like, it's really one of the biggest community I've ever seen. Just think that it was so huge that they had to move away from Slack because the free tier from Slack with the 10,000 messages history will be hit almost every week. So it's actually an active community. Why is this important? Because that means that if we have an issue with this framework, which is still not yet very well known, well, there is someone that is ready to help. And when a new framework surfaces, that's actually really important. And of course, I have to mention again code generation. Because of course, it gives us compile time safety, but it also, well, take away quite a lot of work that we have to do manually. Because we don't need to actually check continuously the schema and the query in order to get our model straight. We just need to get those objects, build everything, and use them. So it's literally 5 lines of code that we need to write in order to have everything already in place. But how do we use that on Android? Well, first of all, we need to add the class path, which is this line here. As of now, Apollo is in beta, I guess, or maybe not even yet in beta, but it's been developed from a couple of years, so it should be reached stable soonish, I hope. But of course, in order to do all the code generation stuff, we also need a plugin, which we need to add. Oh, by the way, if you notice the very subtle Kotlin suggestion, yeah, you should all use those plugins there. I mean, you should always use Kotlin. I will use Kotlin for all the code examples here. Of course, we need also some dependencies. The nice thing is that Apollo already supports RX Java 2. It doesn't yet support coroutines, but if you want to use coroutines with Apollo, it's actually pretty easy. You just need to watch, to take a look on how the Apollo RX2 support is implemented. Is a couple of classes, and just replace with the coroutine constructs, and it will work in the same way. Or if you don't want to do that, you just add the RX2 support, and then you bridge from RX2 to coroutines. But that's, of course, it's another step. But, well, adding all this stuff, well, has some downsides. Because once we add the plugin, if we don't add the schema, or we don't add any file that ends with .graphql, well, our build is going to fail. So as soon as we start with the plugin, we need to have the schema and at least an empty .graphql file. Because otherwise, the plugin will stop our build and say, hey, I don't file the schema, or I don't find any GraphQL file, so I cannot continue building stuff. It would be nice to actually stop this step if one of those files are missing, but still, it's a very young project, so it's one of those downsides that I can definitely live with. Of course, well, when it comes to testing, well, there are not many solutions. Oh, already? Oh, I have to run. Okay, so I'll try to be as quick as possible because I'm at half of the slides. So yeah, I'll make it quick. So we already talked about compile time safety, so I'll skip these. But of course, it can be used with mock web server, like retrofit, basically. So what happens when we make some mistakes in the query? Well, it actually says something like that. Oh, you wrote num, but you wanted name, maybe. And it actually says it right here. So it's really helpful. With mock web server, what we need to do is simply enqueue in a response and pass in the URL of the mock web server, and it will work exactly like retrofit. Oh, whoa. Well, okay, no, it should be below, but that's fine. Yeah, it has been cut more, but that's fine. So, well, okay. An interesting feature about GraphQL is the fact that we don't need to send the query all the times. Since the query is built at compile time, if we need to change this query, we need to change something in the app. I mean, we have to rebuild it at least, right? So in order to avoid sending all this query every time, because, well, this one is small, but imagine when you have to request a huge amount of data, this query really becomes like more and more and more, well, longer than this, like taking a lot of kilobytes. So this is the query, and the request that encapsulates it actually looks like this one. So you have some more overhead, like the operation name, which is the query name, and the variables that you're passing. But it has some other fields. So we just extract the thing that will not change, that are the variables, that actually the variables will change, and the operation name, because this part here will not change. I mean, if it changes, because we have to rebuild our app, so it won't change. And we add something to let the backend know that this is the query that we want to execute. And we do that by adding the query hash calculated from the query itself. With this small request, we can actually say to the backend that we want to execute a specific query that they already have. But, well, it's not said that they actually have it already, because what happens when we use this feature? So basically, we send over this small request. If the backend doesn't have it, it will say, yeah, no, I don't have it. So, well, so you say, okay, I'm going to send everything and the hash. At that point, the backend will save this query, and the next time you'll send the query hash, it will find it, and it will give you back the content. So how do we enable persistent queries? So this is how we declared our Apollo client in our tests. So let's clean it a little bit. This is how we usually would use it. So the way to use this feature, the automatic persistent queries, is just enable them. And if our backend does not support this back and forth, well, it's not a problem, because on the error that the backend will give, it will retry and send over the query. Of course, that means that we send every time to request, which somehow defies the purpose of GraphQL, but well, we can just switch it off and it will work in the same way. So there are also a couple of tricks that, well, a couple of mistakes that I made while using this framework that I wanted to share. So the first thing is that you can name your field, because maybe you don't like the source ID name, but you prefer calling it asset ID. And you can do that. You just need to actually label the field, and when you generate the code, it will be called asset ID or fingerprint instead of source ID and modified. Also, yeah, this line was here, but that's fine. Also, when you use Apollo for Android, remember to always add the type name, because if you don't, when you try to mock your response, it will actually crash because it will expect that that type name is not null. It adds that type name because it has to know what to generate. So based on the schema and the type name, it will fetch the correct object and generate all the classes that you need from that object based on the type name. So if you want to mock your response, you have to add the type name at every node so that when you do the request, you'll get back exactly what you will get back with the Android framework. And also, you can move the schema somewhere else and ask that your class are generated in another package. This has been a huge issue because otherwise it was looking into an hard-coded path on your project, which is fine unless you actually have multiple modules that depend on this framework. Also, if you're a fan of being semantics with Java, you can enable them in your build.gradle file. Otherwise, you will just get instead of get another, just another as a method, which is more. I mean, it's fine, I guess. I guess it's just a matter of preferences. And also, another important thing is that if you change something in the query, you might want to be online. Because if you're using the npm version of the plugin, that means that's something that relies on the npm, it somehow hangs when you try to generate code. I didn't really know, didn't really explore why, but it happened to me on the train that my build was taking like 20 minutes. That was because I wasn't online. So yeah, I guess that's it. If you have questions, ping me outside because I think we are done with the timing. Thank you.